Hey guys, so sorry that I was out yesterday and have to be out again today, but I just wanted to go over what you guys missed not having me there yesterday. So the bell work that you did, the whole point of that was for you to understand that um, it doesn't matter how you look at the car, but you have to be consistent. So if you measured from the front of the car to the next point, you had to look at the front of the car both times. Or if you measured from the back of the car, you had to look at the back of the car for both points from start to finish. And you guys should have gotten six. So that was like page 48 of your notebook yesterday. You should have gotten six, which I think was B or C. I'm not sure. But anyways, that was the answer to that. So I'm just going to run through your notes real quick and just make sure you have all of the answers to your questions. So the whole question that I asked was kind of like if you've ever been sitting at a stoplight and you're totally stopped, you're like in the passenger seat and you see like a big semi or a big bus outside your window and all of a sudden that vehicle starts moving, and even though you're not moving, you feel like you're moving. That's because your brain automatically picks a frame of reference, and your brain in that case picked the wrong frame of reference. So question number one on your notes that are on the next page, I believe page 49, the tree or the buildings in the background or something like that. A bad frame of reference in this picture would be like the clouds, because the clouds could be moving. So if you look at this picture from one to the other, the car definitely did move because we can compare it to the buildings and the tree, and it moved. That was our frame of reference, either the tree or the buildings. Why is frame of reference important? So you can accurately describe the motion. So you're picking the right frame of reference. All right, pretty straightforward. Oh, before we get to the next question, basically these are different examples of frames of references. If you look at picture one, your frame of reference shows you that it's moving really fast. If you look at picture three, you can't really tell. And then picture two, the train's probably moving a little slower than the first picture because your frame of references are the stationary objects outside, and that's how you can tell. But in picture three, you can't really see anything that's stationary with comparison to the train. So you can't really tell how fast that train is going. So you don't have a good frame of reference in that picture. All right, so your next question was, what is distance and how do we measure it? Distance is the length of a path between 2 points, pretty straightforward. And we measure distance in anything that has meters. So kilometers, centimeters, hectometers, decameters, meters, but we do not. I never want to see in science you measure it in like inches or feet or miles. So only something that has meters is what we'll measure distance in. That you should write down is displacement, and you should already have this. Displacement is a little bit different because displacement is the distance in a straight line from your starting point to your ending point. So if you like take a roller coaster, for instance, especially one where you come back to where you got on the roller coaster, you will travel a distance for sure, but your displacement is going to be zero because you came back to where you started. So distance and displacement are a little bit different, and we'll talk more about that in a second. Activity, the whole point was for you to get the difference between distance and displacement. If you didn't do it perfect, that's okay. We're going to practice this some more in a little bit, but this gives you an idea of, I'll show you with my pick. So what I did on mine is I traveled, if you count each little square, I traveled 9 squares or 9 centimeters. But so that was my total distance. But if I took a ruler and laid it diagonal from the start to the end point, the total displacement, which is the straight line from the start to the end point, was only 5 centimeters. So if you've ever heard like old people like me say something like "as the crow flies," that's what that means. It means displacement. It means in a straight line from your start to your finish, how far is it? And so that's why your displacement is typically smaller than your total distance traveled. Okay, this wasn't totally listed in the notes, so you may have gotten a little confused here, but I wanted to tell you. So displacement is a vector. And if you remember a vector, displacement has both magnitude and direction. I also ask in your notes, number 6, how is a scalar measurement different from a vector? Well, a scalar measurement just means it's just a magnitude, it's just an amount. So for instance, if I said, how tall are you? You'd say, I don't know, I'm 5'4", okay? But that is a scalar quantity. You wouldn't say I'm like 5'4" north. That'd sound silly. So that's not a vector. If I asked, how far did you run yesterday? And you said 5 miles, that's a scalar quantity. You didn't tell me I ran, 1 mile north, then 2 miles east, then 3 miles south. You would say, I just ran 5 miles. So that's scalar. But displacement is a vector. And so if I said, hey, go to the store that's 4 miles to the east, and I know I'm using miles and I totally should be saying kilometers, but if I said go to a store that's like 4 kilometers to the east, that would be a vector because I gave you a direction and I gave you an amount. Okay, the way we write these is whenever you write a vector, you write the number and you write an arrow over it, just a little arrow over the top of it, and that just signifies that it's a vector. It doesn't have to be in any particular direction, but if you ever see a number in physics with an arrow listed over it, that means that it has a direction that's associated with that number. So basically, to combine displacement, when two things are or when you have an object that's moving in a straight line, it's very straightforward. So one of two things can happen. It can move in the same direction, and if that's the case, then you add them together, and that's what number one says, and picture A is referring to. So if you look at this car, it moves 4 kilometers and then it moves 2 more, both in the same direction, so we can just add them. So total distance would be 6 kilometers, and total displacement would also be 6 kilometers, okay? But in number 2 and in example B, the vectors are going in opposite directions, so you subtract. So basically the car traveled in 4 kilometers to the right, then it turned around and traveled back 2. So its total distance traveled is still 6, but its displacement is only 2 kilometers to the right. So that's how you solve those. This we'll do some more together, but it's basically the Pythagorean theorem, and I'm going to put everything up just so you can see it at once. So the Pythagorean theorem is a squared plus b squared is c squared. And if you count the blocks on the bottom, you would have, let me use a pen and show you. You would have 1 block, 2 blocks, 3 blocks. So this is 3. Sorry, I know that's not pretty. And then if you go this way, you have 1, 2, 3, 4 blocks. So that's 4. And if over here is your Pythagorean theorem, and it really doesn't matter which one's A and which one's B, but if we said 3 is my A, so this would be 3 squared plus 4 squared, which is my B. Now I can figure out this one side over here. And so this side over here is 5 because 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. And so if 25 is equal to c squared, then the square root of 25 is 5, and that's why this side is 5. So anytime, and all you really need to write down for question number 7 is the Pythagorean theorem, because anytime your distance doesn't travel in a straight line, you can figure out displacement by solving it this way. So let me go back to my, let's see. I'll leave that there. I've got to figure out how to get back to an arrow. Oh, no, that doesn't work. So that's the Pythagorean theorem. I'll run through these real quick. Your exit ticket, so exit ticket number 1, I think Pastor Nathan went over these with you, but number 1 is C, sitting inside the car. That's the only frame of reference that would make the car appear like it's not moving, because the objects inside the car are going at the same speed as the car. So when you compare like the passenger seat to the car, they're both moving at the same speed, so it's going to look like it's stationary. This is also why people get motion sick, because if they're looking at something inside the car, like a book or their phone or an iPad, they're getting their body's getting mixed signals about the car is moving, but the thing they're looking at is stationary. So that's where that motion sickness comes from. Exit ticket number 2. This one was C, kilometer, because it has a meter. Basically, A, B, or C could be used, but C is the best. I wouldn't like to see you like using a meter stick to measure the distance between two cities. That'd be silly and take you a long time. Number 3, if you walk across town taking many turns, your displacement, I think I was in there for this one. Your displacement is B because this one is a vector, but not least. Whenever you have one like this, let me get back and I'll draw it for you. Always, always, always draw it, okay? So if you travel 30 kilometers to the west, if you can't remember north, south, east, west, never eat soggy waffles. And really you shouldn't, they're probably not very good. So if you travel 30 kilometers, it's really hard to write with the mouse, to the west, and then you turn around and travel back 10 kilometers, okay? This would just be like 30 minus 10. So your total displacement is 20 kilometers to the west, okay? And in just a second, you'll get a chance to practice more of these problems, but that gives you an idea of everything that I wasn't here to explain to you yesterday. I hope that helps. If you still have like questions after class or you're super confused, remember you can always come see me in activity Friday, or just shoot me a Canvas message from your phone today and we'll figure out a time to make sure that you understand everything. Thanks for being patient. Please behave for the sub. And I'll see you guys hopefully tomorrow. All right. Bye.